Hello and welcome to the BMC Quick Course series. My name is John Norbeck and I'm a software consultant for the BMC MainView products. In this demo, I will present an overview of the MainView infrastructure. The object of this course is to provide an understanding of the MainView infrastructure and its components, to understand how to navigate in MainView, and to review common MainView terms and commands. So what is the MainView infrastructure? It is the architecture that was developed to provide product integration through intercommunications technology known variously as BBI3, Windows, or MVI. These terms are used interchangeably. The MainView infrastructure integrates MainView products with a common framework across ZOS operating systems. These ZOS systems can be within a sysplex or across sysplexes. The MainView infrastructure is a client-server methodology with a common look and feel across products. Data is collected and transported via a communications pipe known as the data bus. The three components of the MainView infrastructure are the coordinating address space, also known as the CAS, the product address space, also known as the PAS, and the user address space, also known as the UAS. The user address space is the interface into the MainView products. It can be through TSO, VTM EXCP, or the MainView Explorer GUI. The CAS runs as a started task, and there is typically one per LPAR. The CAS contains a product called the Plex Manager, which provides administration and operation views to manage communication links with other CASs, to monitor the activity accessible products that are connected to the CAS, to create context. A context can include a single target system or multiple target systems, and it controls security for the MainView products. The Plex Manager also provides diagnostic views to aid in problem determination. The product address space, or PAS, runs as a started task, and it contains routines, including data collectors, to support one or more MainView products. One or more PAS address spaces can exist on the same ZOS image. This is determined by the product set and customer options. The PAS contains common infrastructure to affect intercommunications that can include the BBI2 infrastructure, also known as full screen, the BBI3 infrastructure, also known as Windows or MVI, and some PASs contain infrastructure for both full screen and Windows. Here is a graphical view of the MainView architecture. At the bottom, we show the MainView PASs and the systems or applications that are being monitored. The CMF monitor, MainView for ZOS, and MainView for Unix System Services can run in the same address space. CMF and MainView for ZOS not only run in the same address space, they also share the same data collectors. MainView for IMS, MainView for DB2, MainView for CICS, MainView for MQ, and Auto Operator can all run in the same PAS or in separate PASs. It is the product address space that collects the data. The CAS manages the retrieval of the data needed to populate a view. The MainView Explorer connects to the CAS, and the same data is used for the 3270 as in the MainView Explorer. There are times when navigating in Windows that it will transfer to a full screen display. BBI2 is the early infrastructure for MainView and is used primarily by the OLTP products, which include MainView for CICS, MainView for DB2, MainView for IMS, MainView for DB Control, and Auto Operator. BBI2 is also known as full screen mode. Over time, the OLTP products have migrated from the BBI2 full screen mode to the MVI BBI3 Windows mode. In this demo, we will focus primarily on the Windows MVI mode. Here we see an example of a full screen display. Notice in the upper right corner the target field. Only one target can be displayed at a time. To view data from a different region, enter the name of a different target. No customization can be done, and there are limited commands. Windows has much more functionality. Some of that functionality includes the ability to customize views and screens, to issue a time command to view online historical data, cursor sensitive help, filtering data with sort, where, some, etc. commands. Multiple targets are possible using context, and multiple windows on the same screen. And there's much, much more. In the remainder of this training course, I will focus on the concepts that pertain only to MVI or Windows. Here is an example of a view in Windows mode. The area of the window are the control area, which are the first three lines at the top of the screen, and they contain the command, scroll, current window, and alt window input fields. There's the window status line, and then there's the display area for the product data. The window status line is highlighted near the top of the view, and the fields are, you can have a greater than sign, a plus sign, or a less than sign, which indicates whether there's data off to the right or back to the left. The window number, and I will show you later how you can have multiple windows in the same view. The view name, in this example it is JCPU. The context, which is the target or group of targets for the data we want to display. The date and the time. The product that we're connected to. And then there's a D or a U, which indicates that it's a distributed view, which is out of the box, or a user customized view. And lastly, the number of lines in the view. Now that we have completed the understanding of what is the MainView infrastructure, let's take a look at how to navigate through MainView. When logging on to MainView, the first screen displayed is the MainView selection menu. From here, I have the ability to navigate to any MainView product in your environment. I am going to select the MainView for ZOS. I can enter Z, and from the next menu a 1, or I can enter a Z.1 to fast path to the MainView for ZOS product. All of the MainView products utilize EZ menus, and each product's default screen is an EZ menu. In this case, EZM ZOS is a high-level list of activities to start. A greater than sign by a topic means that it will hyperlink to another EZ menu. A period will display a view with data. Place your cursor on a specific line and press enter to hyperlink. For more activity menu options, select the MainView for ZOS Fast menu under the Utilities section. The EZM Fast menu is an expanded version of EZM ZOS. There are more specific options in each area. From here, I move the cursor to the Jobs Overview and hit Enter to hyperlink to the J-Overview. We are now looking at the Jobs Overview. The greater than sign on the status window means that there is more data off to the right. The columns that are highlighted in yellow are columns that I can hyperlink to see additional data or to show me other EZ menus. I place the cursor under the job BMC Link B to show the hyperlink capabilities. The results of the hyperlink on job BMC Link B is the EZM job menu with a filter on the job that was selected. Now, if I were to hyperlink on one of the selections in the menu, it will filter the data to only show what pertains to the job BMC Link B. Here is a list of common MainView commands that we will review in the following slides. The bold letters show how to fast path to the commands. There is lots of online help in the MainView products. There's cursor sensitive help, which position the cursor on a field name or in a field and hit PF1 to display the help, or you can enter help in the command line to view help on the field, the view, or a command. You also have the ability to customize field level help. Here is an example of view level help. Place the cursor on the view name in the window status line and hit PF1. There is a description of the view and highlighted topics to see additional help. Place the cursor on a highlighted area and hit enter to see additional help. Here is an example of field level help. To see this field level help, I put the cursor on % delay for devices and hit PF1. For command level help, type help and the command and hit enter. In this example, I entered help space time. Place the cursor on any of the highlighted areas for additional information. For a list of all the MainView commands, type help space commands. Select List of Windows commands, put the cursor on a highlighted command and press enter to display the help details for the command. Use the include mask command to turn on the filter mask feature. Type IN space mask in the command line and hit enter. The filter mask will use the second row of the column header to display or set filter conditions. Add the all parameter to the IN space mask command to keep the filter mask feature on for all views until you turn it off by using the EX mask command. Use the export command to save the current view in a data set or print it to a sysout class. The output of the export command includes all the rows and columns of data associated with the view, even data that requires scrolling to be seen online. The export command displays a panel requesting an existing dataset name or sysout class and formatting options. The data can be saved as is or CSV to use in Excel. Use the time command to display historical data for a specific interval or for a longer duration of time. When you enter the time command with no parameters, a panel is displayed to establish the historical time frame to be displayed. Enter the end date in the same format as displayed in the window information line, as an asterisk to specify the current day, or an equal sign to retain a previously set date. Enter the end time of the interval to be displayed. For example, if you want to see historical data from 3 o'clock to 4 o'clock, enter 4 o'clock. Enter the duration of the data to be viewed in the form of numbers of intervals, minutes, or hours. In this example, we are using 1H to display 1 hour. When finished, hit PF3 or type END to see the historical data requested. Notice the time field in the status line. It shows that the time is 4 o'clock, showing 4 intervals as 59 minutes. The time command can be issued from the command line with positional parameters. The format is time, then the date, then the time, and then the duration. Entering time space asterisk space asterisk space asterisk in the command field will end historical mode and return current data. Single System Image, or SSI, is a feature that allows you to operate with multiple product targets as though they were a single system. You can display view data from multiple targets, perform actions against multiple targets from a single view. The rows of a single view can contain data from different defined targets. This is an especially powerful concept when combined with data summarization across multiple targets. Let me show you that capability. The current view is the cprog view. This view provides general information about CICS programs defined to a context MV CICS 31. The context all command can be issued to view all the CICS programs in all the CICS regions. The results of the con all command can be seen here. Notice the same program name is listed for each region where it is defined. Now, let's say that a change was made to a module and a new copy command had to be issued for a program on each region that is defined. This can be done quickly and efficiently with MainView by using the sum command to summarize the data in a single view. Enter sum in the command line and move the cursor to the program name and hit enter. The sum command summarizes the data and displays one line for each program across multiple systems. In this example, we can see that program BALPUTLV is defined to 10 CICS regions. By entering new in the line command field to the left of the program, the new copy command is issued for this program on all 10 CICS regions. In a single system, the MainView architecture consists of a CAS, the coordinating address space, and any number of product address spaces. In Windows mode, each PAS is connected to the CAS, which is connected to a user address space. The MainView Explorer runs as a separate address space and also connects to the CAS. When a user requests data, a view definition notifies the CAS as to the product, context, and data records that are needed to fill the request. The CAS collects the data from the PAS and sends it to the user address space where the data gets formatted into a view. When there is more than one system, the user only needs to be logged on to one CAS. The CAS communicates using XCF in the same sysplex, or TCP, IP, or VTIM across sysplexes. So if a user is logged on to sys-A and they want to see data from sys-B, then they can issue the context command to see the data from system B or from both systems in the same view. MainView Explorer connects to the CAS and therefore has the same functionality of accessing data on other systems. System C has now been added to the CASplex. All systems can be accessed by logging on to only one. The MainView Infrastructure connects them all together. Here is an example of a screen. A screen is multiple windows with view data in the same display. Notice that in window number 1, we have MainView for COS product with a single context of sys-B demo. Window number 2 has MainView for CICS with a context of all. Window number 3 has MainView for DB2, and window number 4 has MainView for MQ series. You can have up to 20 windows that may be opened at any one time. A context is the name created to represent one or more targets for a specific MainView product. Context can be a single target, a context of all, which includes all LPARs or regions defined to a MainView product. Users can create context definitions by using the Plex Manager product. Context groups can be created by LPAR, production, test, QA, by DB2 data sharing groups, by CICS, AOR, TOR, or FOR groups. To learn more about context and creating context, look for the quick course series on MVI context customization. Thank you for your time. For more information about MainView or any BMC mainframe product, please visit the URL shown here.